All right, we're going to look at transformation of functions today, okay? There's several types of transformation. A transformation changes the size, the shape, the orientation, or the placement of a function, okay? So we're going to look at the functions in general because this all applies no matter what the parent function is. If it's a constant, if it's linear, absolute value, or parabolas, quadratic, the transformations treat each function exactly the same no matter what the function looks like, okay? So there is two types of transformations. Overall, we have vertical and horizontal, right? So we have our vertical transformations, and we have horizontal. So make two columns. And then these are the directions in which it moves. Vertical is which direction? Up and down. And horizontal is left and right. So we have translations, which seem to be our easiest. A translation was up, down, or left and right. Right? Translations happened when we added or subtracted. For the vertical, it looked like f of x plus k, or f of x minus k, right? When I added k, a number, to the outside of the function, which way did it go? Up, right? When I added k, it went up. When I subtract k, it goes down. So this is up and down. Now the horizontal translations gave us f of x minus h and f of x plus h. Now when it was f of x minus a number, which direction did it go? It went right. And when it's x plus a number, it went left. Opposite of what we think, right, should happen. We want to say if I'm subtracting, I should go to the left because negative numbers are to the left. But it does the opposite for the horizontal. Okay. The next one we looked at was reflection. No, I don't want this. Fix this in this. There we go. So the reflections. How did we get reflections? We multiplied by a negative, right? It's hard to see well. Try to move it out of the way here. There we go. So reflections happen when we multiplied by a negative. A vertical reflection reflects over what axis? The x-axis. The vertical reflection was over the x-axis. That was f, the negative f of x. The whole function got multiplied by a negative, and it reflected over the x-axis. And the horizontal reflection was over the y-axis, right? That happened when we just made the x inside the function negative. So are we noticing a pattern of where we worked in order to get a vertical translation?
Worked on the outside.
We're working on the outside, right? We're adding or subtracting on the outside. We're multiplying on the outside. That gave us a vertical translation. So let's add that under vertical. Outside the function. And so in the horizontal, everything is happening so far inside the function, inside the parentheses, inside the absolute value, eventually under the square root. Everything horizontal is inside the function. So let's add that. So then the last type of transformation was the shrink and stretch. Might as well put it in a different color. Okay, the shrink or stretch. I feel like we got a pretty good handle so far on the translations, the reflections, most of the time, at least being able to describe them. But the shrink and stretch just got confusing, right? Because that oppositeness of the horizontal kind of always tripped us up, okay? So let's talk what it looks like. Let's see. So for the horizontal, for the vertical, we said everything happens on the outside, right? So we multiply by a on the outside, a times f of x. A is the factor, so we say vertical stretch factor of a. And if a is greater than 1, what did it do to the function? Stretched it, right? Stretched it away from the x-axis, right? And I'm going to write away from x-axis. And if a was between 0 and 1, and really we're talking about the absolute value of a, because the negative reflects it. The negative doesn't affect the shrink or stretch, right? It reflects it. So it's really the absolute value of that number. Don't pay attention to the negative that we look at. So when it was between 0 and 1, it was a shrink. And it was a shrink towards the x-axis. We're saying the absolute value of a means if this is, say, a negative, the negative reflects it. The number itself without the negative. So the absolute value of that number, the absolute value of negative 2 is positive 2. That's what we're looking at to compare greater than 1.
So the negative technically doesn't affect our shrink or stretch?
It does not at all.
Okay, it's just
the negative reflects it.
It's something else. Okay.
Yes. So we look at the absolute value of a. I want to make sure we're writing it mathematically correct, right? Because if it's negative, it's the reflection. You don't want to say, oh, well, it's negative, which is less than 1, so is it a shrink or a stretch? No, it's the absolute value of that number that makes that determination. Because remember that a ultimately is the slope of the branches of your absolute value function. It's the slope of a line. It affects the steepness of a parabola, but a parabola is a curve, so it doesn't have slope anymore. And we'll talk about those in chapter 2. So the horizontal happened on the inside, and I'm going to use a different variable here. I'm going to say that's f of bx. Because it isn't the stretch or shrink factor. This is the number that goes into my equation. It's the slope of my line. It's the slope of the absolute value branches. But the factor A, so we have a factor A is equal to 1 over this number B. Right? The shrink or stretch factor is the reciprocal of the number in the function, 1 over B. So if this is a 3, my factor is 1/3. If it's 1/3, my factor is 3. Okay? And the same information applies as whether it's a shrink or a stretch when you look at the actual factor, not the number in the equation. So my factor, it's still if A, absolute value A is greater than 1, now we're talking horizontally, so we're talking about it going away or towards the y-axis, right? So we stretch away from the y-axis. And if it's between 0 and 1, we shrink towards, I'm running out of space, the y-axis. That says, this says towards. I can't fit it. So they kind of look similar, the shrink and stretch, depending on where my vertex is, okay? And we can tell from a graph whether it's a shrink or stretch based on how the vertex got changed. Remember that a shrink and stretch changes the shape of it. It gets steeper or narrower, shrinks away, shrinks towards the y-axis, shrinks towards the x-axis. Verticals, it depends on which way it's all moving. And I'm going to show you 3 graphs next, okay? I have 3 graphs here. The red function is my original. One of these graphs was vertically stretched and another graph was horizontally shrunk. We can see and tell which was which by looking at how the vertex moved. My original vertex, to go to the blue graph, got stretched down. So because it moved down, this is a vertical. It moved away from this x-axis, so it was a vertical stretch. My vertex started at -3 and is now at -6. So what did we multiply by to get the blue graph? We had to multiply by 2. So this would be a vertical stretch factor of 2. To move to the green graph, it moved towards the y-axis, it moved horizontally. So we can talk about whether it shrunk or stretched away from the y-axis. We can clearly see it went towards the y-axis, so this is a horizontal shrink. And what did the vertex get multiplied by to move it from 2 to 1? It got multiplied by 1/2. Notice that my equation for the blue here represents that my vertex is now at -6. The y value, the x value stayed the same. But my equation on the green changed my vertex, the x value of my vertex. And we can see with the 2 inside, to find the vertex just from the equation, we would have to take 2x minus 2 equal to 0 and solve that, and we get x equals 1. So my equation represents inside. When I changed the inside of the function, it horizontally changed it. The number inside the function is 2, but the factor is 1/2. And since 1/2 is between 0 and 1, it was a shrink. It moves it towards the y-axis. Number 2, or the blue graph, got multiplied by 2, and notice that there's a 2 out front the absolute value, and the 3 also got multiplied by 2 to stretch it to the -6. And that's the factor of 2, and it's Let's look at a couple examples of describing a function in function notation. Then we'll put it into a different function and see how it changes slightly or how it's the same. So with my first f of x minus 2. This is inside. What's happening is inside, so it makes it horizontal. And from our first slide, the notes we took on that, when I subtract a number, it does the opposite of what I think it's going to do, and it moves to the right. And it moves to the right, too. So we say it's a horizontal translation right 2. And if we have f of x plus 2, the plus 2 is on the outside of the function, so this is vertical. It's adding, so it's a translation. And vertical always happens with the exact sign that we think it should happen, so plus means it's going to move up 2. If we have f of 2x, the 2 is inside, so we're talking horizontal. And I don't want to talk about whether it's a shrink or a stretch until we look at what the factor is. The factor, remember we said that b, the number inside, is 1 over b is equal to a, the factor. So my factor in this case is 1 over 2. Well, since this is between 0 and 1, it's a horizontal shrink factor of 1/2. So our next example is f of x plus 2. We're looking inside the function, and inside is opposite. So we want to say that it moves to the right because positive is to the right, but it moves opposite. It's a horizontal translation to the left 2. Then 2 times f of x, multiplication is shrink and stretch, outside is vertical. And our factor, so vertical, the factor is exactly the same. A is the number in front. So because a is greater than 1, it makes this a vertical stretch factor of 2. If I have a negative in front of the f of x, we said a negative outside the function, vertical reflection. The vertical reflects over the x-axis. The graph is up here. It reflects it. My vertex moves to the other side of the x-axis. If I have f of negative x, this reflects it over the y-axis. I have it over here. Now instead it moves to the opposite side of the y-axis. And lastly, if I have f of x minus 2, again, it's outside the function, it's addition, subtraction here, so it's a translation, vertical translation, vertical transformations happen exactly the way the sign tells us, so it's down 2. let's look at a few functions already written. Let's say my function is f of x equals 2x plus 3. This is a linear function. The parent graph is f of x equals x. So if I'm describing the transformation from the parent graph, I can say this is a vertical stretch. Because the factor is 2, which is greater than 1. And outside the function again, plus 3 is a vertical translation up 3. And we really want to talk mostly when we describe it in the order of operation. So this multiplication we're going to talk about first, and then we'll talk about the addition. The only time that's different is when it's inside the function, inside the absolute value, inside the squared, and then of course it's opposite, just like everything else horizontal. So let's look at one of those possibly. F of x is equal to, let's say 2x minus 4 squared. The parent function is f of x squared, which is a parabola. So here we'll describe it first, the horizontal translation. So this is a horizontal translation to its opposite, so it's right 4. And then it's followed by a horizontal. And let's talk about what the factor is before we decide whether it's shrink or stretch. If it's 2 inside the function, then my factor is 1 over that, 1 over 2, so it's a horizontal shrink.